Hi, everybody. Glad you could make it to get together for a discussion about climate change. My name is Chip Fletcher. I'm a professor of earth sciences and associate dean at the School of Ocean and Earth Science and Technology at the University of Hawaii at Manoa. So let's dive right in. We want to take this opportunity to talk about some of the realities of human greenhouse gas emissions and how the enhanced greenhouse effect works. We unfortunately missed our opportunity to solve the climate emergency back in the 90s and even 10 years ago in the 2000s. So now, not only do we need to continue with mitigation, which is the process of ending greenhouse gas emissions by substituting renewable energy for fossil fuel energy, in everything from motorcycles, cars, all the way up to power plants that provide our electricity. But we also need to engage in very significant adaptation because we've set in motion some extremely dangerous climate change results. There is long-term sea level rise, which is going to displace hundreds of millions of people on the nation's coastlines as coastal communities get flooded. But then we have more extreme weather events that we need to adapt to, such especially as extreme heat waves, drought, and then storms of various types. At the same time, we need to very quickly ramp up our efforts to sequester, especially carbon dioxide, which means to pull it out of the atmosphere and pump it into the crust into geologic strata, which we know will hold it, prevent it from leaking back out to the atmosphere. There are various ways to do that, but additionally, as an interim step, we can pull CO2 out of the atmosphere and make useful products out of it, such as jet fuel. Now, jets would burn it, the carbon would go back into the atmosphere, but we would recycle it and pull it back out again. So we'd be using this sort of synthetic fuel, or recycled carbon rather than introducing new carbon in the form of burning fossil fuels. And of course, education needs to be a constant in our society, especially for our elected leaders who need to come to understand the realities of climate change so that they can make the courageous decisions that are necessary in order to protect us from an even worse future. So the greenhouse effect is what is behind climate change. The greenhouse effect is a natural process which keeps Earth's temperature above freezing as an average mean global temperature. If we did not have a natural greenhouse effect, the average temperature on the planet would be below freezing and life as we know it wouldn't exist. Unfortunately, by releasing greenhouse gases which trap heat that would otherwise escape into space, we have caused the natural greenhouse effect to become an anthropogenic greenhouse effect. It's trapping more heat than it would normally because we release these greenhouse gases. And we're raising the temperature of the atmosphere, which is leading to some very negative impacts. So sunlight is the ultimate control on our climate. It comes into the atmosphere, and if it happens to hit a bright white surface, such as sea ice or snow or glacier, that reflects the sunlight back out to space, and it does no work with regard to climate change. But if sunlight does intersect a dark surface, such as a body of water, the oceans, or even the land, it will absorb that sunlight, it will warm up, and it will re-radiate a new type of energy called infrared energy, which we know commonly as heat. So we see this every day walking across a parking lot or some other dark surface as it gets heated by the sun during the course of the morning and around noontime. It gets hotter and hotter and it's releasing heat. Now that heat would normally escape to space, but the greenhouse effect, because of these gases, principally carbon dioxide, will trap some of that heat and then re-radiate it in all directions, some of which is back down towards Earth's surface, heating the surface a second time. The more greenhouse gas we have, the more reheating of Earth's surface takes place, And that is the process of trapping additional amounts of heat. So we refer to excess heat or trapping excess heat in the atmosphere as the anthropogenic greenhouse effect. Once you warm the air, however, the most powerful greenhouse gas of all begins to accumulate, and that's water vapor. Now, water vapor will only increase in a long-term sense in the atmosphere if the atmosphere gets warmer, because we are all learned back in 6th grade about the water cycle. We know that the average water molecule only lives in the atmosphere for maybe a week or two. And so it's very difficult to permanently increase the water vapor content of the atmosphere unless you warm it. And warmer air holds more water vapor, which is what we refer to as humidity. And so this is called an amplifying feedback effect. For every 1 degree of warming that you get through carbon dioxide and the other greenhouse gases, you get an additional degree of warming through this natural feedback of increased water vapor because the air has become warmer. We know the history of carbon dioxide accumulation in our atmosphere. It's now up to 415 parts per million. The natural level of carbon dioxide during non-glacial times, such as we live in today, you hopefully have heard of ice ages. We currently live in an interglacial between ice ages. The typical CO2 content is around 280 parts per million. So we are approaching a 50% increase in the natural amount of carbon dioxide in the air, something that hasn't occurred for over 3 million years naturally. And this carbon dioxide traps heat that would otherwise escape to space. And so we see the increase of heat in our atmosphere. Heat is, or the temperature of the lower atmosphere, which is what we measure in climate change, is highly variable because of things like the El Nino, La Nina process and longer term processes that take place, all of which engage in storing heat in the ocean, principally the Pacific Ocean, or releasing heat from the Pacific Ocean. And so each one of these warm years, those upward peaks, is probably an El Nino or a near El Nino event, which is a process that releases heat from the Pacific Ocean into the air and creates an anomalously warm year globally. And each of the downward spikes is either a volcanic eruption, which can push particles, ash and sulfide particles into the atmosphere, especially up into the stratosphere, which is the next layer of atmosphere above the troposphere, which is the layer we live in. Up there in the stratosphere, it's very calm, and particles that are erupted up that high will reflect sunlight and actually lead to global cooling. So the more volcanic eruptions there are, we'd actually tend to lower global temperature, but it is temporary. Eventually those particles fall out after 6 months or a year or maybe a year and a half, and you go back to what the temperature would have been anyway. We know CO2 accumulation is accelerating. We know that warming is accelerating. We've currently warmed the air globally about 1.2 degrees Celsius. This is equivalent to a little more than 2 degrees Fahrenheit. You know, when you're walking out on the street and you go into the shade and then back out into the sun again, you're experiencing a temperature change which is more than 2 degrees Fahrenheit. So what's the big deal with this warming? Well, the big deal is that it is a permanent warming. It's analogous to having a low-grade fever. Imagine instead of 98.6, you had a fever of 100.8. That's the equivalent of what we're doing. And if you had that low-grade fever, you would not feel well. And various things would go along with that that negatively impact you. We are on track to warm about 1.5 degrees C at the end of this decade, which would be analogous to a 101.3 degree Fahrenheit fever. 1.5 degrees C is also a milestone that the United Nations has established as, and that the world's nations have signed on to stop warming at that point. And a more definitive target set by the United Nations is 2.0 degrees Celsius. The idea there is that we must avoid that amount of warming because of the extremely dangerous extreme weather events and chronic stressors that will be a result. And by chronic stressors, I simply mean the continuous rise of air temperature, sea level rise, etc. Now, I'm going to explain in the next several slides why it's highly unlikely that we will be able to stop our greenhouse gas emissions in time to arrest global warming at 1.5, and in fact, at 2.0 degrees. As evidence of the accelerating rate of warming in the first 80 years of the 20th century, on average, there was a new global temperature record set every 13.5 years. But since that time, we have set on average a new global temperature record every 3 years. So here is the data collected by NASA starting in the late 1800s, which shows temperature changes around the globe. By the time we get up to especially the end of the 1970s and into the 1980s, you'll see a very rapid increase. You can already begin to see it here. Some of the features to note here are that continents are warming faster than ocean basins, that we have large blue areas in the North Atlantic and in the Southern Ocean, which are cool temperatures in the ocean because of cold meltwater streaming off of the Greenland ice sheet and the Antarctic ice sheet because of warming taking place. And always keep in mind that a warmer ocean provides fuel to hurricanes. And so, in fact, we are seeing hurricanes intensify from a lower category to a higher category extremely rapidly these days. Global warming and warming of the ocean is not thought to create more hurricanes. It is thought to create more powerful hurricanes. And it is changing the tracks of hurricanes. So at a location such as the Hawaiian Islands, it is projected for this century, and in fact, we are already seeing more hurricanes because they are tending to migrate towards the poles. That is, they're migrating away from the equator. And historically, hurricanes have passed to the south of the Hawaiian Islands if they make it out to the North Central Pacific Basin that we live in. But now they're migrating away from the equator and onto the same latitude as the Hawaiian Islands. All right, so we emit carbon dioxide from burning fossil fuels. About 86% of the emissions into the atmosphere every year come from burning fossil fuels, but another 14% comes from our land use practices, principally deforestation, which results in the release of carbon from forests, rainforests principally. Of that emitted carbon dioxide, 44% will go into the atmosphere. It can take many, many centuries, even over 1,000 years, before all of that emitted carbon dioxide is removed from the atmosphere. It continuously declines over time, but it does have this very long residence time. And of the emissions that we release every year, 29% or so immediately goes into photosynthesis or to the biosphere, where it is stored in the form of plant material, woody material. And another 23% goes into the oceans. It is dissolved into the oceans Carbon dioxide plus water leads to an acid called carbonic acid. And so the oceans their pH is lowering, and this is a process called ocean acidification. Greenhouse gas emissions are now equivalent to about 40 billion tons of CO2 per year. This continues to increase. China is currently the world's largest emitter, with over 25% of all emissions coming from China. But over the last several decades, it's the USA that has been the largest cumulative emitter of carbon dioxide, with 25% of all cumulative CO2 emissions. The poorest countries emit less than 1% of greenhouse gases. However, they tend to suffer the greatest impacts in the form of disruptions to food and water availability, and suffering at the hands of extreme weather events because of poor infrastructure. Under current policies, expected warming is projected to exceed 3 degrees C by the end of the century. This is equivalent to having a body fever of between 104 and 105 degrees Fahrenheit, which is pretty darn high. You would want to go to the hospital. From 2020 to 2024, so over the next 4 years, it's expected that there is a 20% chance of mean annual temperature actually exceeding 1.5 degrees C in at least 1 year over that time period. So this relationship shows atmospheric CO2 emissions or buildup in the air on the vertical axis, and world GDP or economic activity. And since World War II, we see that there is a very direct causal relationship. This is the economic relationship we need to break. We need to continue to have healthy, non-extractive economic activity without emitting greenhouse gases. And by non-extractive, I mean, in addition to climate change, human overpopulation of this planet is leading to some very negative impacts that I'll talk about in a minute. Instead of constantly extracting from Earth in a way that is not recycled or regenerated by natural Earth systems such as groundwater or soil or forests, lumber, we need to discover a new economic model which is focused on sustainable use of natural resources. And this is often referred to as regenerative economic activity, or a circular economy. That is one that is based on truly recycling and reusing the materials that we produce. So with only 1.2 degrees of warming, we have already documented Antarctic ice melting has tripled over the past 5 years. Greenland melting has quadrupled in the past decade. Greenland and West Antarctica are both now irreversibly melting. There's nothing we can do to stop their eventual meltdown, even if we were to stop emitting greenhouse gases today. There is, in fact, a 5% probability, according to a statistical poll of the scientific community with expertise on glaciology and sea level rise, that sea level rise could reach 5.5 feet by 2100, 6.5 feet by 2100. This is 2 meters. We have documented a 12% global increase in extreme rainfall and a 10% global increase in drought. Climate change amplifies the problem of overpopulation. We've already altered 70% of the world's lands with mines, roads, industrial farms, cities, and airports. 40% of the world's original forests have been eliminated, and we continue to engage in deforestation. Since 1970, 50 years ago, the per person consumption of material has increased 45%, and world GDP has grown by 300%, all on a planet that has not increased its capacity to provide natural resources. Today, there is a freshwater crisis on the planet. 66% of humans face a water shortage for at least 1 month every year. Over 33 million people were displaced from their homes last year in 2019, and climate change played a role in 70% of these cases, very often in the form of extreme weather disasters. Poor women are 14 times more likely to die from a climate-fueled disaster than men are. The Syrian conflict that gave rise to ISIS and to a refugee problem that has changed the political face of Europe, think Brexit, started because of a 1,000-year drought in Syria and other parts of the Middle East that collapsed farming, causing millions of farming families to stream into the urbanized areas of Damascus and Aleppo, where they found a lack of government services and realized that they were being governed by a corrupt government of President Bashar al-Assad. This led to the young men forming a rebel force and a civil war. And at the same time, we were pushing al-Qaeda out of Iraq. They found safe haven in the Syrian political chaos, and that gave rise to ISIS. That 1,000-year drought that was the beginning of that process was made 2 to 3 times more likely by climate change at the time. Annually, extreme weather disasters cause more than 60,000 deaths, and hurricanes are bigger, they rain more, they are moving slower, which means they do more damage, and they are intensifying from low categories to high categories much, much faster than they have in the past. And IAG, the insurance giant, has said that failure to reduce greenhouse gas emissions could result in a world that is uninsurable, with poorer communities bearing the largest burden. We see amazing papers now being published by the premier journals of science and Nature. This paper is titled "Pervasive Human-Driven Decline of Life on Earth." Points to the need for transformative change, and it says that the world is increasingly managed to maximize the flow of material contributions from nature to keep up with rising human demands for food, energy, timber, and more, and with global trade increasing the geographic separation between the supply of natural resources and where they are used, their demand. This unparalleled appropriation of nature is causing the fabric of life on which humanity depends to fray and unravel. So as I mentioned, the United Nations Framework Convention on Climate Change has been meeting, in fact, every year for a couple of decades. In their 2015 meeting, they finally found agreement with all of the world's nations to stop global warming before reaching 2 degrees Celsius, and to pursue efforts to end warming before 1.5 degrees Celsius. Unfortunately, these reductions in greenhouse gases that all of the nations agreed to are self-policed. So there are no actual controls on whether or not a nation adheres to their pledges. Hence, we see, for instance, a continued rise of the use of fossil fuels at rates that are growing faster than renewable energy. For instance, here in 2019, you can see the growth of gas, coal, and oil has a steeper climb, a steeper curve than all of this cluster of renewable energy, non-fossil fuel energy below it. In fact, renewable energy is not actually replacing fossil fuels. It is helping meet the demand for new energy around the world. And this is what coal did and oil. When oil was discovered, it really didn't replace coal. It simply accelerated global development, and it moved in as a partner to coal to meet the demand for new energy. And so the world's energy economists are in uniform agreement that we will be seeing continued energy-related CO2 emissions towards mid-century. You can see this list of groups that project global energy. They provide projections into the future in annual updates. And you can see they all agree here that CO2 emissions are projected to continue to increase. If we want to see global warming stop at 1.5 or 2 degrees C per the Paris targets, this is the pathway that needs to be taken on CO2 emissions. So let's look at that pathway. Here along the bottom axis, we have the time history from 1850 up to 2075. And on the vertical axis, we have global carbon dioxide emissions in billions of tons per year. And this is the 150-year-long story of CO2 emissions, actually 170 years, right up to the year 2020. And if we want to meet the Paris targets, literally this year of 2020, we need to begin to decrease emissions at an average of 7.5% per year, so that by 2050, we are at 0 greenhouse gas emissions globally. And in fact, thereafter, we need to remove CO2 from the atmosphere because we're likely to overshoot 1.5, and the removal or sequestration of CO2 will allow us to come back to 1.5. If we want to target 2.0 degrees Celsius, there is the pathway. We must have 0 emissions 15 years later by 2065. And as I mentioned, we have to continue removing CO2 from the air for centuries. This is a very difficult proposal, and very few people who study this topic seriously believe that there are any signs at all that we can do this. So renewable energy provides only 10% of global power. The top fossil fuel producing nations of the world are on track and have announced plans to produce about 50% more fossil fuels at the end of this decade than is compatible with stopping warming at 2 degrees C. China is building more new coal plants today than the rest of the world combined. India is opening 41 new coal mines as part of its post-COVID recovery plans. Coal, in fact, remains the single largest source of power generation around the world, accounting for 36% of global power in 2019. Renewable energy provides only 10% of global power. To get to net zero by 2050, the world requires reductions in carbon emissions, just like we have achieved so far this year as a result of the pandemic. So we need to do these 2020-like reductions in emissions every other year for the next 25 years. And the reductions in carbon emissions this year have come at the expense of our economy. The number of unemployed has tripled since the beginning of the pandemic in late March in the United States, up to 10% unemployed because of the pandemic. So this can only be achieved by a radical shift in all our behaviors. COVID is currently forcing us to make this shift, but what will the post-COVID economy look like? Will it come roaring back powered by fossil fuels? Will it come back slower but powered by renewables? And is COVID here to stay as a quasi-permanent condition that really suppresses economic growth and slows or stops global warming because our release of CO2 is confined because economic growth is confined? So the last modeling that was done on projecting continued emissions and therefore future global temperature on the basis of economic considerations was this paper by Raftery et al. In 2017. They project a likely range of warming between 2 and 4.9 degrees Celsius with a median likelihood of 2.3 degrees C. This same number between 3 and 3.5 degrees C is produced by other folks estimating future temperature as well. So this is looking like a pretty robust projection. At greater than 3 degrees C or even greater than 2 degrees C, we're going to see growing food and water availability, disrupting societies, a growth in extreme weather disasters and intolerable heat. Global scale refugee crises will develop because large parts of the continental tropics will become unlivable, potentially displacing as many as 3 billion people. There will be extreme damage to the ocean and to terrestrial ecosystems, and we may have already set in motion several meters of sea level rise, perhaps as much as 17 feet of sea level rise just 2 centuries from now, which will wipe out most of the world's major cities because they have been built at ports, having first been settled when the era of shipping was the primary means of global trade 200 or 300 years ago. So here is a recent paper, and it is only one of several. This is called The Future of the Human Climate Niche. It identifies today a couple of locations in black, deep in the Sahara Desert, where already the temperature is too hot for human existence. That is, a fully healthy person could be sitting in the shade at these annual temperatures and die due to heat-related illness that same day. And within 50 years of global warming, this 1% of land area will expand to become 20% of land area. Too hot for human existence. We're looking at most of the northern portion of South America, much of Central America, most of North Africa and the Middle East, almost all of India, Indonesia, Malaysia, Thailand, and other parts of Southeast Asia, and the northern portion of Australia. The human population in this area is projected to have to move, and we're talking about 1 out of every 3 people on this planet will need to find new locations for living. So this is the pathway. CO2 emissions continue to grow. I'll show you the pathway. It'll be a red arrow in just a second. Let's do a brief review of emissions recently. There was a 1.5% increase in emissions in 2017, a 2.1% increase in 2018, a 0.6% increase in global CO2 emissions in 2019. And as I mentioned, during the pandemic here this year, 2020, the year has not yet closed out, but we are projected to see a reduction in CO2 emissions someplace between 3% and 8% reduction. That needs to continue. We certainly hope it won't be because the pandemic continues. We hope it will be because common sense begins to take over our economic activities. And this red arrow is the pathway we currently are on over 3 degrees C of warming. You can see that in this cluster of future scenarios, the pathway we are on is not the worst, but it is still extremely dangerous, taking us over to 3 degrees Celsius. And I will end with that. Thank you very much for your attention. And I hope to see you all again. Bye-bye.